Okay, good morning. Happy May 4th to everybody. I was glad to see some of you come to the parade on Friday. It was a lot of fun, so I was happy to see some happy faces. I hope you had fun if you came. Um, anyway, today we're starting a brand new packet, and it's called Number and Operation Packet, and it's under Classwork. If you click here, you'll find it. You could also go to school and pick up a paper copy. It's not necessary. Don't feel like you have to make a special trip, but some people like it on paper, so I have it already printed out for you at school. Okay, when we go to the number and operation packet, we're going to skip topic student handout 1. We're going to come back to that, but we're going to start with student handout 2. And what it looks like is right here. So I'm going to have you guys open that up, take a look at it, and get out student handout 2. Okay, so let's talk about adding and subtracting integers. Just as a reminder, integers are either positive or negative numbers, right? And if you remember my wonderful number line at school, we had positive numbers go this way, negative numbers go that way. Integers can also be added and subtracted using an algorithm or set of rules. And this is just a memorized set of rules, but you really will get used to it. You don't even have to memorize it because you'll understand it once you start practicing it. But in general, when adding, if two values have the same side, then you could sign, then you could add and use the same side. So if two numbers are positive, like 6 plus 5, then your answer will be positive. If two numbers are negative, then like negative 6 plus negative 5, it will equal negative 11. If the signs are different, then you subtract and take the sign with the greatest absolute value. So that means here we have a positive 6. And remember, we usually never write it like this, positive 6. So the positive sign is invisible. But if we have a positive 6 plus a negative 5, what we do is subtract the two numbers, and the sign is always the greatest number, right? So the greatest number wins. 6 is bigger than 5. The absolute value of 6 is bigger than 5, so that's why it's a positive. Here we have negative 6 plus 5. Well, that I subtract because the signs are different. So negative 6 minus 5, right, is 1, or 6 minus 5 is 1. And then the sign is whoever's the biggest guy wins. But let me show you that with Algebra Tiles, which I don't have, but I'm going to give you a clean whiteboard so you can see it. And I'm just going to start with the examples that he has given me in the book, okay, or on the handout. Okay, so I'm just going to start with his examples. And if you could see, the first one is negative 9 plus 6. Well, how would we do this? Let's try this way. All right, so let's start that. I would like you guys to do it this way first, so you could kind of look at it and see why it works. I want you to take two different colors. And for 9, I want you to draw 9 negative signs because it's a negative 9. So I'm going to use red for negative. 1, 2, 3, 4, 5, 6, 7, 8, 9. And for positive, I'm going to use black. How many positives do I have? I have 6 positives. Remember, there's no positive sign in front of it because positive signs are invisible. So 1, 2, 3, 4, 5, 6. I try to line them up because what happens is a negative and a positive cross out. 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 And how many negatives do I have left? Well, I could count them. 1, 2, 3. So my answer is negative 3 here. Notice how my rule works. Remember what the rule was, though. If the signs are different, you subtract. So what is 9 minus 6? Well, that's 3. And who has the bigger number? Well, of course, the absolute value is 9 is bigger than 6, so that's why it's a negative. Not too bad. I would suggest you start by writing those out like that so you could really see it, okay? So let me clear that, and let's start with now this problem. In my positives, I'm going to make them black. And remember, there's no +7 minus a -3 here because the plus side is always invisible. Notice, notice how he puts parentheses around the -3. You might see that sometimes, right? You might see that sometimes. All it means is 1 times -3. And then all it means really is that he wants you to know that the negative is attached to 3. I'm actually not even going to, I'm not even going to talk about that invisible 1 yet because I don't want to confuse you. But when he put parentheses here, he's really just saying that that negative sign is attached to the 3. Okay? So how many positive 7s do I have? Well, 1, 2, 3, 4, 5, 6, 7. And how many negative signs do I have? Okay, 1, 2, 3. What did I say we do with the positive negative? Cross them out. And then how much do I have left? Well, let's count. 1, 2, 3, 4. And so my answer is +4. Remember, we don't write that. We just write 4. We don't write the plus there. But as you can see, I have 4 plus signs left. Now let's look at our rule. Are the signs different? Sure are. 7 and -3. When the signs are different, what do? Well, the rule is subtract. So 7 minus 3 is 4. And then who wins the sign war? Well, that's the plus sign because 7, the absolute value of 7 is bigger than 3. So the answer there is +4. Okay, I'm going to do one more and then I want you to finish this page and then we're going to talk about subtracting integers. Okay, I'm going to do this one right here. Okay, so now I have -6 plus a -8. Remember what I said about those parentheses? Those parentheses means just the negative sign goes with the 8. So how many -6s? 1, oops, sorry about that, guys. 1, 2, 3, 4, 5, 6. And how many negative signs do I have? 8. 1, 2, 3, 4, 5, 6, 7, 8. Did any positives come in and cross anybody out? Nope. So when the signs are the same, these are the same signs. It's a negative and a negative, right? When the signs are the same, you just add them together, which is 14, and they're both all negative signs. And we could just count that out, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And so my answer is -14. Or it could have looked like this, 6 plus 8. Well, we know they're both positive, and we know what 6 plus 8 is, 14. So it could have been that if that was the problem. But that's not the problem. The problem is -6 plus -8. Okay, not too bad. Let's talk about subtraction, okay? Okay. So when a number and its opposite are added, the sums are 0. This is similar to adding 0 pairs with counters. Okay, we kind of know that already. That means if I have a +6 and a -6, that's going to equal 0, right? But when we are subtracting integers, we want to rewrite the problem to add the opposite, then follow the rules for adding. So what this means is this, and I want you to kind of get in the habit of doing this. Let me move these over. That means what we're going to do is when we see a -5 minus 9, whenever I see a minus sign, I want you to get in the habit of doing this. Boom, boom. Because we're going to change everything to addition and adding its opposite. And it works for minus signs. So let's do this. 8 minus a -3. Okay, what did I say we do? Boom, boom. You change the plus, the minus to plus, and then change the signs. So let's look at this one again. -2 minus a -10. Well, what did I say we do? We change the subtraction sign to a plus and then change the sign of the second number. We never change the sign of the first number. He's always okay. And then we just follow the rules we do for addition, okay? And that might seem confusing, but it's really not. I'll do some problems for you. Okay, so here we have 9 minus 6. Well, you're going to tell me, Miss K, that's 3. I want you to get in the habit of doing this, which means changing that minus to plus and then changing the sign. So, 4, this one right here, 4 minus 7. I want you to get in the habit of changing the minus to plus and then making that a negative number. Okay? And for this one, it would be negative 7 minus 12. Boom, boom. Okay, so minus turns to plus, and then you change the sign of the second number. I want you to get in that habit because that's going to help you when the problems get really difficult. You know, I learned this back in my 6th grade year, and I still use it today, even in really, really hard math problems. I always change that minus to plus, and then the second integer gets the sign changed. Okay, so let's start using this as an example. Okay, so I'm going to do this one. Okay, so negative 9 minus a negative 9. Okay, what did I say we do to this minus? We change it, and then the second integer gets changed to a plus. So what does this turn out to be? Negative 9 plus 9. Okay, well, I know how to do that. I have 9 negatives, 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many positive 9s do I have? How many positive signs do I have? Well, I have 9 positive signs. So 1, 2, 3, 4, 5, 6, 7, 8, 9. These we say cross out. Boom, boom, boom. And as you can see, I'm left with 0. So negative 9 plus 9 is 0. So that's my answer right there. Okay, let's try negative 7 minus 12. So my problem here is negative 7 minus 12. Remember what I taught you? This changes and that changes to a negative. Remember the rules. If there's 2 negative numbers, all you do is add it. So 12 plus 7 is 19, and that's a negative 19 because both are negative. Wow, that's a lot to learn in one lesson, right? So don't worry, you don't have a lot of homework today. All you have to do is try this, okay? I know that some of you might be confused, but I want you to try this. So I'm just assigning the homework 1 for this, okay? And then we'll come back and finish stuff, but just homework 1 for today. All right, guys, have a great day. Bye.